Okay, so before we start today, I shared this with my CYSA class last night. I wanted to let me make sure I have audio. Okay, so I wanted to share with you some opportunity that you might be interested in applying. I encourage you to look for internship every summer, fall, right? These are usually full-time positions. They're not exactly in Inland Empire, but these are with big corporations. Some of them require high clearance. Boeing is contracted with the government, as you know. So if you are interested, if you go to Boeing website and you type an internship like what I did, there are many opportunity in El Segundo. If you're familiar with El Segundo area, they're right near the military base out there. And you will be reporting there. Most of these positions are full-time. So they run all kinds of engineering internship. If you're in the STEM program, I periodically send out a STEM internship list. But once I do that, I will share with everybody in my classes. And that's part of like just the process. My schedule is a little stacked this week, so tomorrow I might have a little bit of time in the afternoon, so I'll work on this. But if you look for Boeing, they have, some security-based type of program. There's also AI programs, but in different locations. So when you look, you just gotta remember to look for California. And so you can go through these and see if you're interested in applying, whether you want to get into some, analysis, some kind of assurance, which is typically ties back into security. And then if you want to get into software engineering, I know some of you are computer science based, but you can start with them. My aunt was a former Boeing engineer. She went to Cal Poly Pomona, retired at 50. She did really well. If you ever go on the plane that's made by Boeing, and if you see the screen that show you the simulation and all the video, she worked on that project. Also, flight simulator for the F1 jet fighter for the pilots. She also did some Sharp projects with, so if you use Sharp TV, the menus and everything that was written in Java was originally created by her team. So I encourage you to check this out. Also, there is a couple, oh, I lost it. But anyways, this thing also has cybersecurity opportunity along with, I know I shared this throughout last week as well, along with Panasonic Avionics in Irvine. And these positions pay between $24 to $45 an hour full time. Some of them require or prefer that you have a bachelor degree, but if you're on track to get your degree, I think you're eligible to apply. Some of them have a minimum GPA requirement, 3.0. So most of these scholarships and internship program will require a grade point average. So try to keep up with your grades. And then typically they require that you're also a full-time student or sometime have to be currently attending. We are an accredited college, right? So anytime that you go to community college or university, we are, all the institutions are typically regionally accredited. So you can check out some of these applications, but I will try to put together a list so that when you have the link to take a look at the job, if you want to apply, I encourage you to do that outside of, looking on LinkedIn and other search engines. So this week we are going to cover Unit 3. As last week, we talked about a little bit of reconnaissance techniques and tools. So this week we are going to work with server a little bit more. And banner grabbing is a major area in ethical hacking and pen testing. I can't emphasize enough on how you need to really understand, right, the communication of the server, because web servers are typically the systems that you see coming in from the internet, right? And that's what the attackers see. So you need to really understand how web server works, how some of these servers communicate to really identify the issues that you have on your networks. And pretty much everybody have a web server, right? Whether you're thinking about a small company that's running web apps so you can order food from, like a local restaurant, to major company like Amazon, Microsoft, right? So they don't just have one, they have many because it's typically a cluster. So today we're going to talk about OS fingerprinting. We talked about footprinting in the last week. The difference between footprinting and fingerprinting is really looking at the software side of your system and also the version of the services. So if you're running Apache 2, it will tell you specifically which version. Why is that important for us? It's important because the version that you use will speak to the weakness of your system, right? All software have weaknesses, so we want to understand a little bit more, and that's going to help us better develop our system, better manage and secure our system. So when you're working with web server, a lot of the times it's going to tell you a response. So if you ever open your browser and type in the wrong URL, right? You get like a 404 error message. That's a status code, okay? So the server is designed to give you a response. These codes really represent whether it's successful, it's failed, it's pending, it's moved, right? So if you have a server that's been relocated and rehosted in another system, you're going to have some additional status code. So we have to be familiar with these status code if you're going to be a pen tester. And even as an analyst or an incident response specialist, you have to understand how these systems talk, right? So at the beginning, it talks about analyzing your status code and making sure that you are looking at the request. So this is how it works, okay? So if I'm the user, I'm sitting here and I open up my Chrome, Firefox, or Microsoft browser, right? I type in the URL. My system then sends that information from my network, which typically at home, that will be your wireless network. At school, that will be your school network, right? And it's going to try to locate first the domain. So your DNS is going to be identified, the local DNS, and then the destination DNS. And in the case that if it is redirecting some website, sometime that you see that it's redirecting to another server, that's going to go through the process when it enters into the external network, right? When we're leaving our local network, when we entering into another network, right, your service provider or google.com, for example, we are simply reaching out and connecting through other networks. That's how the internet works. So what you're going to see is once it reached the destination domain, like google.com or microsoft.com, the first byte that you're going to see is going to tell you what's happening with your communication, whether you're successful or it's failed, right? And then once you have a successful status, it's then actually going through and submit a request. So TCP works in 4 ways. First, it's going to say, hey, is that server there, right? Using the public IP address. So it's saying, okay, and the server responds, I'm here. Let's talk, right? And then your system is going to then, I am requesting this content, right? So loading the page, typically that's going to come back as HTML. And the server is going to say, okay, here is my service content, which is typically your web page. So that's when, once you have a synchronization in the data, this is when you get that page that you see. So the content actually loaded back into the user system, right? And then it's going to load additional content of the pages. So in the case that if you are trying to sign up for an account, right, it's going to allow you to do a set where your activity, typically if you land on a page, it's going to be a GET request with HTTP. So why is this important? It's because in the attack phases, you are going to have to understand the process of how we start until how we end. Because the attacker, they really map out all of these things And in the case of you using encryption, right, to fill out forms and so on, then they're going to start saying, okay, at this step, I am going to do this. I'm going to perform this attack by stripping, right, your encryption, by stuffing the packet, by changing or redirecting your traffic, right? So if you understand the process of how you start to how you end, right, when you're visiting access or even locating web servers, that's important. And every web server is tied to a DNS, okay? All right, so let's go through and answer number one. So why are web server responses important? I mentioned that web server responses contain successful or failure connection. It tells us whether we're able to reach that domain, right? That web server and the DNS server, or we didn't. We failed, right? So if you type in a URL that is incorrect, and because you're trying to reach a domain that doesn't exist, you're gonna get a status code that's gonna be a 404, right? Which is error page. It cannot locate that server, so that's a failed connection. But if you are successful, like let's say I go to youtube.com and it's gonna give me the synchronization and loading on the page. In the status code, in the back, it's gonna show 202. That means that it is successful, right? This is gonna help us on the admin end. So if you become a system admin, you basically deal with these servers, right? Your team is gonna maintain and develop the content for your web server, and you just gotta make sure that your server is responding as it should, right? So when you're managing it, you really look at how successful are your customers. If you're an e-commerce company, if you want to have web presence, and if it's not giving you a lot of connectivity, then we can understand why it's doing that. We can use it to troubleshoot, right? We can also see like how our content is loading, right? How our users are using the web content that we are providing. And then ultimately, everything is interconnected. And with that, we would also see the security component on the elements of security, right? Encoding, in network connection, in the service that we're using, how that can be improved. So overall, you have to understand a little bit of web development, web design, and also web connection. Okay. All right, so what I did was I went to Mozilla, right? I gave you the link, and you can always reference Mozilla content. Everybody, by standard, follow these. This is universal to everybody in the world. So you know that in the world you have millions, right? Well over 10 million servers that are giving you what you see as the internet. So whether it's hosted in the United States, Japan, or somewhere else in the world, right? What you see is everybody follow this schematic for status code in web development. So before you start looking into some of these codes, I want to show you where you can get the information. So if you click the link, right, it tells you the range. So if you're seeing 100 to 199, that represent information responses. So that's just giving you like some status with your content. And then if it's successful, that's going to be in the 200s. Redirection is typically 300 to 399. And then when you get the error, that's the 400s. And then if you're, so the client error, my browser, right? I typed the wrong URL, you're going to get 400. But if something is wrong with your server, like maybe it's not communicating correctly, it's not connecting, it's not networked correctly, it's not configured correctly, then you're going to get a 500, okay? So how do you see this? When you are grabbing banners, you might see the status code, right? Basically, you send that request to see if what it's respond, and then it's going to give you the information, what it has, what is configured, what kind of OS and services it has. So if you get a 500, that means that the server is failing, right? So we can look at that list and it breaks it down to the specific. So I wanted to list some of the basic status code because these are useful to you, right? As you might aspire to be a pen tester, you might be doing more web app security later on, or you might be working with server administration, like as a sysadmin, right? So these are going to be important for you. So in number 2, it tells you to look at the link, and we're going to go through and look for some of these status code. Okay. For 102, basically, if the server receive the request and it's currently processing the request, but it has not responded, you are going to get a 102. Like there's a pending response, right? It's kind of like, when you're shipping a package and let's say you order a product and that person started to ship your package, but there's no confirmation with your shipment company yet, right? So you're going to get a 102. The server has not fully responded, but it did receive the request. So there's no complete handshake that's happening yet, right? When does this happen? Maybe there's latency or delay in web connectivity. You know this. Sometimes you go to a certain web server and it's slower than the other web server, right? Sometimes that they're hosting the system with limited resources, or the connectivity is not all there, right? Or there's some latency or slowdown in that process. But it did receive some information and it hasn't responded, right? When you get a 200, that's simply everything succeeded. There's a handshake. It received the request and it acknowledged. Okay. So this is when you scan the network, it's going to be a synapse, right? And 204 is also a success, but the resource is then there's new resources. So if this typically, when we do Wireshark with this, we would see get is when it loads the page, right? Post is when there's something submitted to that page, right? So what you see is if the response is sent after the post request, then it's going to do some put requests. So these are like the tasks that the servers executes, right? Get loads the HTML on the client browser application, right? Post request is when you're trying to submit some kind of information to the server, like filling out form. So you get a 204, that means that it receives the request, but it not yet received your posted information, your submitted information, or your put request. Okay. So again, that might be a little bit of latency on the server side or the connection between you and that web server. Okay. Now for 301, if you are using a URL that is changed permanently. So for example, I might have a company ABC, and I previously have a domain called abc.com. Now, I have decided that I don't want to use that URL anymore. I want to, redirect or permanently change that URL, possibly because maybe I'm growing or shrinking, right? So if there is a permanent change in the URL and you typically redirect it to another host that's using a different URL, like xyz.com instead of abc.com, then you are going to receive a 301. Then a 305, this is when you're using an older version of HTTP. So you would see that there's HTTP 1.1, and then there's 1.2 or a newer version. A lot of companies are currently using, if they created their website a while ago, they might be using an older version. So what you see is 305. It's going to indicate the request response, and it's going to send it to a proxy. So proxy is a system. It's a middleman. It's used to regulate traffic. Okay. It's kind of like, you know how there's accident on the freeway and the police has to step out of their car and send everybody into a detour lane? Proxy does that. So what we can do is we can make all our traffic go through another system, one for screening, right? Sometimes that can slow down your network. Two, to be able to have the proper redirection to the request, right? It can be sent from that system to another system and putting everybody through that. So for example, right, if Google put up proxies, they typically have many, right? When you type in youtube.com, it's going to send it to proxy A, right? And that proxy A is going to determine which server of youtube.com, because they have many, server A is going to receive your request. But then your friend goes to youtube.com from his house or her house or their house, right? It's going to send to proxy C, right? Which is going to then forward to a different server. So this is a way that we can regulate traffic and we can service many different requests all at once. So when you are using a proxy to regulate that, you typically get a 305 and it usually works with HTTP. Let's say that I use an old HTTP version and I use a proxy to be able to submit that for my web services. So that way maybe I can control security components, my network, right, etc. Because we don't typically pull everything down and upgrade right away. We wait, okay? In phases, even if you're using an older version and it is vulnerable, a lot of times you want to control that so that way you can phase in the new technology and the new package. Okay. So now when you get a 400, that typically is that it's not able to process your request, right? Maybe you type in something wrong in the URL, so your syntax in your URL, right, is invalid. You see this 404, 400. So 400 or some kind of request in the message that it cannot frame it. So the system is pretty simple, right? If it's receiving malform requests, it's going to be like, I don't know what you're talking about. And that's basically that, right? So it sends back a 400. It says, you did something wrong. I don't know what you're requesting. Okay. And so it can't structure that request and cannot respond to it. Then you have a 401. This is to specify unauthorized. The response means it's unauthenticated, and in itself, right? The client is going to receive this message. So some websites, right? Let's say that you have a portal for remote access, and you basically require an authentication component in order for that client system to be connecting to a certain part of your network. And if that user doesn't submit the proper credential or that system doesn't have the right token in security, what you're going to see is it's going to send back, it's going to say, uh-oh, I cannot let you through. You cannot get this request because you didn't give me the appropriate credential. A security token typically just tells the system what it's allowed to have, right? And when you're receiving the web content, basically it's like HTML or certain form of script, so that way it opens up the content for you to access. And in a portal format, typically that takes you to other applications or other resources on your network. So it's not able to process that as well. And then 403, 403 tells you that you don't have access rights to the content. So in addition to authentication, sometimes that we lock certain content is only for certain type of user or certain system, right? So in the case that if your system or your user doesn't have access rights, then the resources cannot be given back. So it cannot be responded with the resource. Okay. And then you rarely see 413, but if the request is larger than the limits that's defined in server. So in web development, they must right, by practice, to really size down. You want to be able to control, right, what is being requested, because if you don't, you're going to run into security issues and also buffer overflow and other issues and resources. So if it is larger than what typically a limit would be, so it's kind of like you're in the classroom and I tell you, you're only allowed to ask me 2 questions, right? But you came to me with 10, 15 questions. So the server is like that. It's gonna say that, oh, it's only gonna be able to handle a certain size request in the payload. Then if it's more than that, then it's gonna drop it. Okay. We do that so that way we can control, number one, bandwidth. Two is the resources, because every request goes to RAM. That's where the processor is gonna fetch the information. If it's not able to fetch the information because it's too much, right? It's gonna drop it, because you don't want that to sit on RAM. That takes up, and so they can actually perform an attack that way. So it's gonna close the connection, and then it's going to reattempt, because HTTP is part of TCP. TCP is going to give it a reattempt. TCP, make sure that you have, right, appropriate communication instead of like using UDP. UDP is like, oh well, if I drop it, I don't care. That's, then the user has to request on manually, right? On TCP, it's going to do a retry after, right? You see this when you go to your browser and it says that it cannot be connected at this time, maybe it's busy. It's gonna say reload, or it allows you to be able to click the reload option, so that way it's gonna reattempt again, right? So in some cases, you might have large requests and you see a 413. This sometimes is an attack, sometimes it's like, it's not administered properly. You do see some of that, but rare. Okay, so what kind of information can be found on web server in the response body? So I'm going to give you the breakdown. Everything in your system is going to have some form of header. That's kind of like if you are shipping a box, the header is like the label on your shipment, okay? It's going to tell other systems that this is the format, this is the type of service that it's used, and you see that everywhere. File has header, right? So that's like the label that we use on shipment. So HTTP is the same. When you are using your scanner today for lab, you're going to see headers. That's where we're going to pull a lot of information from. So it's structured or framed with that. It's going to start with the header, and it also have a trailer, right? Which is the ending of that frame. So it tells the system that this is the complete thing. It's kind of like, the post office have the weight and everything for your package to make sure that it's in its entirety. And inside the content of your shipment is going to be the body. So in HTTP, the body, right, typically contains your data, okay, what you're requesting. And the format is in JSON or XML, okay? So if you ever hear people doing web scraping, they pull data from different web servers, right? Typically that comes down in these two formats, JSON or XML, okay? So that's what you see quite a bit, because that's how it's designed. Any question? So I mentioned this a little bit for number 4, right? The purpose of HTTP header and what do they contain? 1, it provides an instruction or the metadata for the server response or the requested resources. It's kind of like your shipping label. It tells the shipping company where your package is going to go to, right? And what kind of package that would be. So when they scan it, they know that, oh, it's supposed to go to this zip code, this particular network, right? And your package, if there's fragile item, right, they would see that on the label, and so they're going to handle it with care. So it's basically instruction for the system to understand what it needs to give you back in the content. Okay, so when we look at the stuff today for lab and here on out, right? You're gonna have a couple of web-based server type of activity. You are gonna see the headers, right? And so be familiar with that because all of these scanners are designed to pull the information for you. So it's gonna look at the request and it's gonna look at the response and it's gonna tell you what that system has. Okay, so I'll move 3 and 4 down to the next page as some of you are working on that. And I didn't complete number 4. And then it also let the client and the server pass additional information with the request and the response, right? Like I said, I might be shipping something and I would tell the shipping company that I have fragile item, I have liquid in here, and they need to handle it with care, right? So there's additional information that might be needed in that communication so that way the server knows how to respond. And then it is case sensitive name. It's following by a colon, right? And a certain value. So anything white space is ignored, okay? So the headers, that's how it's formatted. It is case sensitive. Now you have 2 types of header. One is the request header. That's coming from your client system, right? The system that you're using with the browser application. The system that's asking for web content. 2, the second type of header is going to be your response header that comes from your server, okay? So 2 types of header. So in number 5, it tells you to describe the content. The reason why I make you see this and write it down and hear it, so that when you remember and when you see it, you're like, oh, okay, that makes sense, right? You can apply the concept. So in the request header, it contains information about the resources that needs to be fetched, right? Or it could be about the client requesting the resource. So if you're using your browser, let's say I use Firefox and I type in a URL, right? Then it's going to refer to that destination server. And the fetch part is all your system has processor, and your processor needs to be able to fetch it in order to process, right? So it's gonna queue that and put that on ramp. And then it's gonna go there, it's gonna say, oh, this is the ask or the request from the client system. Now, on the client side, in web development, some of you have taken web development classes, right? They tell you you can make it where it tracks which browser the user is using, right? And we would only allow specific browser, right? You notice that sometimes Canvas or certain platform is more friendly, right? Some website is more friendly with specific browser. Like if you're using like Apple-based browser or Microsoft browser, but then so they usually develop for the more common browser. So it does have that information, right? The requesting system, the IP addresses, and the actual, so it logs all of that. This system from California, United States, this public IP address is requesting and using this application to access the web content. And it really depends on how they design the web resources, but typically that's the practice. So I was telling my 41A class we have to be able to track that because we can see, right? And we can control like how our web resources is distributed. Then on the server side, you have a response header. This is going to hold the information on what the type of response that it has and the location about the server is providing. So if your server, right, is hosted in United States, right, at a cloud center or a data center, it would then have that information. Okay. Typically addresses, right, server information, the type of services that it's using. Then the re-representation header, this contains the body of the resource, right? Such as your MIME type or your encoding compression applied. And if you are in this field, you know that we use UTF-8 for encoding, right? I know a lot of computer science students are like, well, what about ASCII? Well, we use ASCII too for text, but ASCII is limited. So if you do a lot of coding and web development, typically you use UTF-8 because it is more of a broader encoding system. This is universally accepted. So why the encoding system? Well, it is a way that we can format things so that way the content is universal and so that is displayed to someone in the global perspective, right? It is a system that we use to be able to format a certain text or, so that way we can display it. So even if you have another language on the website, like Chinese, Japanese, right? Thai, then you still use the encoding system, the character, the content, and the practices, the standards is going to be the same. Okay. So this, think about representation really pertains to content and data, right? That's the body. There's so many headers. You're going to see there's packet header, so basically that's like the label, the things that would show you some information about that particular communication. Then your payload header, I mentioned to you last time, anytime you hear payload, that pertains to bytes and data, right? So it contains what is represented, which is typically the data, and it is independent information of that data, okay? Content, encoding, and to transport. So this typically, the easiest way to understand this is download and upload. So when you download, right, your content, your download files is going to be broken into many packets. So let's say that I downloaded a video that's very large. So my downloads, typically you see it as one entire download, but the way that the system works is if it's a large file, it breaks it into chunks. And then when it gets to your system, it puts it back together. Like we talked about the bicycle last time in the networking concept, right? So in the system, it's going to limit it to a certain size. So in a large download, it chunks it up, and then it's going to send it. So the representation of your data and the length of the content is limited to the maximum size that it's going to be able to send, right, or respond, and the encoding that's used to transport. We use one or a few encoding systems so that way, whether you download a PDF or, a doc or whatever, right? It's still going to refer to that one system for transportation purposes. It's like going to the post office and say, I want to send a bicycle. They're going to tell you these are the size of the boxes that we support, right? You either take apart your bicycle, which we do, right? And put it in the boxes because you cannot send it in a huge, large box, right? They only allow you to have a certain boxes to send, and that's how you would send it. And that's what the system does. It chunks it up to digestible, sendable sizes, so that way when it gets there, it pulls everything together. It does a checksum, and it's going to say the payload is 5.1 megabytes, right? And these are the packets that needs to be able to accumulate and give you this content. We do this very quickly now because our infrastructure is fiber for most part, right? There's a big push that your service provider is fully fiber, so that way you have what you see as 5G and the communication that you need in instantaneous, right? But if you go somewhere else in the world, right, your payload, if you're trying to download 5.1 megabytes on a slow network, even your server is fast. When it gets there, it's still going to have to put everything together. It's kind of like slowly unboxing and then putting everything back. So if you understand networking and web development, all the puzzle pieces going to pull together, right? In these classes, what we're trying to do is to give you the pieces and then glue them together. And you're going to say, oh, that's what she said when we learn about networking. And this is what she said when we look at, our headers. And then you have a general header. This specifies just the general information about the response, such as timestamp, okay? And the server type. I mentioned to you, 90% of your web servers are Linux-based, right? Apache 2. Apache 2 is the current package. You do have Microsoft servers, web servers running IIS. Okay, we are going to put up some IIS server locally so you can see what that's like. So doesn't matter the type, right? It's going to specify that whether it's going to be NGINX with Apache, or IIS for Microsoft. Then you see the headers information and the timestamp. So the date, the content for data delivery is going to go there. So these tools are only effective if you know the result, what they mean, right? So I tell this to my 41A student, as an analyst, you get paid to interpret that information from your scanner and put it on paper. That's the bread and butter. Okay. Because it's not about copying and pasting the command and just see what's on your screen and take a screenshot for the lab. I ask that you look at it, right? If you don't know, call me over. I will explain. And then also explore that information and say, what do I see here, right? That's the important part about, applying your skills, because people get paid a lot to do this, right? Okay, so any question regarding the last few questions in the assignment? So hacker target, some of you are taking 41A, right? Sometime we're going to be doing the lab and you are going to pull this particular package, a module, okay? So in development, we do modular design. That means that you run an application and you can pull in additional feature for the application. It doesn't load everything all at once. So I have an option to pick like the feature that I want to be able to scan. Okay, so let's say that we're using an API. So what's an API? It's an application interface program. It's a program that talks to another program. Okay, and so what we can do is we can bring in the module, which is a program, right? And we can use it with things like Nmap or other scanner. And we want to be able to identify things that is relevant to security. Okay. So I want you to visit the website, and hacker target is a common one. Okay. So this is what you see, right? Is it completely user-friendly? Oh, they do the best as they can to give you the results. Okay. So remember we talked about HTTP version, right? You see that right there? Let me see if I can increase the font so you can see. If you are visiting google.com, you are going to get an SSL because it's an HTTPS, right? And HTTPS encrypts. It uses encryption, either SSL or TLS there. So then you see char set. This is your encoding scheme, your system, right? And the content type, it tells you text and HTML. And then any additional things, right, that would be content security policy, reporting only in these criteria. So the rules are set there. Remember we talked about the general header, that's your timestamp right here, right? And then the response header, you see that? GWS is the server name. There's no cross-site scripting protection, your XSS. That's called cross-site scripting, right? And so this tells you a lot of information. We learned about the status code. Originally, you have a 302. In the next phase, there's a 200. So that's a success. And it was successful at this time, right? Sometimes they put an expiration on that particular session because you don't want that to keep going forever. That just ties up your bandwidth. So what can I do with these resources? You can use this to look at specific responses, right, from the header or the request header, so that way you can gather more information on your target. Let's say that we don't do this for Google. We do this for our company's website that we're pen testing for. You use this, you use the API, and you plug in the parameter of your URL, right? Your web server is going to respond. Its job is like to answer the question, right, of the client. And then you can see status code, is it successful? Can it be communicated? Cache control. Cache is used for buffer, right? And it's used for a lot of things like fetching and so on. And then content length, your server information, and if there's cross-site scripting protection. If there's none, then potentially that can be a weakness, right? So they typically would have like anti-clickjack and then anti-cross-site scripting. So the good web developer, they would have that element. But sometimes it depends on the domain. Sometimes that's not important for public server because there's not a lot of things that you can inject. In Google, right, if you go to google.com, where can you type in the information? In the search bar, right? So if they control the input for that, people can type like 5 paragraphs into the search bar, and it's gonna crawl and it's gonna spit out the result. But if you type a script in there, guess what happens? Drops the response, gives you an error, right? So they typically control that through the application itself. So I want you to look at what you see here, right? Try to interpret it. So if there's compression, you see that with the encoding we talked about, you see that in the description for the things that we saw earlier, right? Also cookie information and the type of cookies that's used. This is important because cookies contains credentials sometimes, it contains session, and from a session hijack perspective, right? A lot of the times they're going to examine your cookie. And then you see H3 that pertains to the port that's relevant to your server. So like 443 or 444 is typically used for HTTPS. And then remember, transfer is chunked. Of course it's chunked because for bulk files, you can never send like 5 meg or 3 megs. Typically they're in bytes, right? Like 300 something. So less than half of a kilo or less. Okay, so that's a little bit of information for you. Do you have any question on 6? Okay, so before we answer 7, let me take you to the notes. So I talked about status code, right? Just have a good reference for it. Mozilla is your best option to go to. They have like how to use DOM, DOM effectively, how to build, your content for your page effectively. And then so your request is going to come from get, post, or put, right? Get is to load your HTML page. Post is where you submit to a form, like you input text, or put. Okay. Okay, so let's talk about banners. So every server has some kind of banner, okay? And it is a way that we can understand how your server respond in the context of the request, okay? So the banner typically contain about the server itself, right? The software version, the name of the server. You saw that, right? GWS for Google. So FTP server is the same. It's going to have this information, And then occasionally you might have some details about that server. Why is this important? So from an attacker standpoint, I am going to study your system as much as I can because that's going to tell you the weaknesses on that system by the version of software or how it's configured. And I can use that for exploitation. From a pen tester perspective, we're going to do the same. We're going to understand how weak it is, and we're going to find ways to fix it, okay, to make it more secure. So FTP similar to HTTP, but what it's going to do is first it has to establish connection, right? Then it's going to give you the banner. I did the lab with my 41A class last night, put up an FTP server, right? If once you connect to that server, it's going to tell you name. You can see if you can type in anonymous or test user, right? And then see if you can authenticate that user. So they will type in the password. Once it's in, right? In the back, the server is going to say, here I am. This is me. This is what I'm running, right? That's what it's going to say. So when we run a tool to scan, it's what we look at the process. We're going to try to grab this banner and we're going to see what type of things that this server contains, okay? Like the information about the server. Okay, so how can I grab a banner? Okay, so when you perform web scraping, that's also part of like pulling the data, and it's a little bit into banner grabbing. Okay, so you would use OSINT tool. This is a TO, sorry, I had a typo there. Things like Nmap. Nmap is regularly used in this industry. This is an active, right? It's an active recon tool. So it's going to fingerprint the information about that server. You can also use Netcat, Nictel, and curl. Curl is just it's CURL, right? It is just like a way to connect or to download. Same thing with wget. If you see some of my lab, I have you do a git command, or sometimes if you just need to visit a website, you can use a wget command. So what that does is it submit a get, right, task to the server request. And so in Linux, we would do a wget. And then if telnet is available, typically admin would turn this off. In security, we turn off telnet because telnet allows the system to remotely connect and see everything in plain text. You want to use SSH instead of telnet, so that way it's encrypted. So, for example, if I need to configure my router, my switches from home, right, I can connect to it via telnet or even locally. But you want security because someone can intervene and access your information. So you want to use SSH instead, right? So typically telnet is turned off, firewall by default. Windows turn that port off anyways. But it is still there. So in the banner grabbing attack, it basically reveals your protocol, which is service, right? Like FTP or SFTP, which is secure FTP compared to non-secure, right? And then the applications through your software packages. So if I'm running Apache 2, it's going to tell me Apache 2 version 2.4.2, etc., right? And how that can be used for exploitation. So when we're running these tools, it's going to tell us the common vulnerability, the weaknesses in the software, and the weaknesses is what they use. So whenever you see like security attack, usually that's just an exploitation on things that are flawed, right? So whether it's communication flawed or application flawed or configuration flawed, all of those kind of tie back to what we see with the type of job that we're going to be doing. Okay. Same thing with recon. We are going to actively grabbing a banner. That means that you are going to communicate with the system directly. You're going to send packets or requests to that host and wait for it to respond, right? Where passive banner grabbing, you're just obtaining that information with no direct communication to that host, you can use something like a software or a platform to be able to identify, like, see what's going on with that host or if that host exists. So for 7, the purpose of banner grabbing and pen testing, it typically just tells us software information about the server. It can use to identify and remediate vulnerabilities. So we do this so that way we can find the flaws that we have on our systems. And we want to be able to remediate, fix, remove, right? Patch. Sometimes you cannot remove because that's the only service and protocol that's used, and that's the current type of service, right? So you would have to find alternative way to secure that particular element. So to obtain FTP server operating system, so all server has some kind of operating system, whether it's running Linux, Windows, right? Now, sometimes it's going to come up as Unix. Unix is the grandfather of Linux. So you might see that come up as a result when you scan your system today, right? So when you grab the banner, you can use things like Nmap, which is active scanner, right? You can use Netcat. Netcat been around for a long time. You can use Nictel. I had a typo there. It should be NKTO, also an active scanner. You can use Curl, which is a command-based tool that's equipped with Linux. You can use Telnet. It's also command-based. It has its own CLI as well. You can also use it through an application like PuTTY. You can also use the command wget. So wget allows you to connect to that host via URL or an IP. Okay, so now we're going to talk about secure shell. So that's one form of server is your FTP. FTP server is designed to distribute files, right? Share files. So for example, my company might have an FTP server. I can use it to have folders of forms for, let's say, my customer. To apply for loans. I can use it for my customer to upload some of their information, but then you need to make sure that it's secure, right? So FTP is a way that we can download and upload files. Typically, you organize everything through folders. Now, on SSH, I told you earlier that another way that we can securely connect to a remote system is using secure shell, SSH. Okay. The same port that's used in SSH is used for secure FTP. So you can also grab the banner for SSH server. This is going to contain the server's identity, typically your host name, the version of SSH that is using, the configuration for SSH server, any kind of changes or updates to that service, and warnings and notification that it typically send to the requesting system or your client system. So anything that is responding to client requests, typically we can pull a banner. Like your HTTP, your FTP, your SSH server. Now, does the server system, server systems can be just like your powerful computer. It can be specifically with certain type of hardware, but typically it would run OSs. In Windows environment, you have to use server OSs. You can host server with web server with like Windows 10, right? Like let's say I'm a small company. I have a powerful computer at home. I run Windows 10. You can run web services on that. Just like how you're using Kali Linux, you can run web services on it too, right? So, but in practice, we typically use a server OS, right, to run server because it has more feature. So you would see that, right? Like if they're running Red Hat for Linux or Fedora, it would say that. I think a lot of people move away from proprietary Linux like Red Hat because Red Hat you require license. Because Microsoft require license. So typically you see Debian-based Linux that are open source, right? Like you see like if it pulls up Debian, similar to Kali and Ubuntu. So you see releases like that. So they don't. So server you have to pay per seat. That means that if you have 10,000 people connecting to your server, in a proprietary environment like Microsoft, you pay for that, right? So that way the system can be connected and can get access to resources. But if you use open source, this is why web, because we don't know how many clients we might have, like millions of requests. Right? You think about Google and YouTube, you got many requests. So it doesn't make sense to have licenses for proprietary product. And sometimes they build their own, right? Google might have their own version of Linux, which is what you see with Android as a variation of Linux. Okay, so in SSH banner, it will be useful for security configuration because it's going to show, right, the warning messages, the disclaimer, and it tells the administrator how it informs the clients that's connecting. And in that case, if someone is trying to access it in an unauthorized way, they don't have the key, right? SSH uses encryption, so it requires a key. If they don't have the appropriate key to access, right, then they are going to get some kind of response, a warning error, okay, or a warning message. And in most cases, we would incorporate the monitoring for the activities in that session once it's authenticated. Now, this is a way that we can look at how we can deter, right, attempts for unauthorized access. Okay, so if we know this, we would then have the same information as your attacker, because your attacker is going to do their homework by looking at your banner. They're going to be like, well, what kind of security does your system have? And the easiest way is to pull your banner and say, oh, this is the thing that they have on their SSH server. So the banners can also be used to tell the client system the rules that is set for that server. Because when you're accessing the server has rules that it checks, right? And how it enforces those rules, like through authentication, with security token, by, not allowing certain things. So that's what you see. Because we don't want to open everything up once they're connecting, right? You also have different level of users that are connecting as well. Like the IT members that are using SSH server for remote configuration is different than your remote workers that are using SSH server to access specific systems at work. Okay, they still have to go through remote access server, which is another server that brings them there. So the way that we use systems is we take a system, we set it up to connect to another system, and each system has its own service, right? It's kind of like you take the plane to fly to another state compared to you drive a car to go to work locally, right? So you use servers for different type of purpose, okay? And these banners tells you their purpose and their job and who they are. Okay, so we talked a lot about software, right? And when we're pulling software information about the server, what the server is running, we're actually doing fingerprinting. Okay. So fingerprinting gives us operating system information. You saw this with Nmap when we did lab 1, right? I had you put down like capital V switch with Nmap, tells you the version, right? So you can look for specific software information. Operating system is a software. So to break it down, I know some of you are taking 21, right? CIS21. And some of you have taken 21 or have taken it at a university, because computer science operating system class is slightly different than just operating system class for IT. In IT, we look at operating system version and configure, right, like Linux, Windows, and Mac OS, compared to computer science operating system classes, and I've taught in both, is really the design of the operating system. You must understand what an operating system does, right? It is a way for the user to interface with the system to manage their objects like files, right? Resources in the system. So the server does the same thing. It needs to have a software so that way system can interface it, user can interface it and configure it. And so what you see is that operating system is then used. Well, what about embedded system, right? When you look into IoT, a lot of these things also have operating system. Your Android is an embedded system. Your Google Nest, your TV has something that's run in the back. It might not lay out like your typical operating system, but it does have operating system structure. Now, the ones that are lacking operating system are the microcontrollers. Microcontrollers are only used to execute certain purpose. For example, the sprinkler, right? Turn on the water and spray for 5 minutes. Turn on. So basically, it activates that circuit, right? Sends that signal, open up the sprinkler, spray. Same thing with your Christmas lights, right? Now, some systems are more advanced, so like you can program in it. Typically, it has some kind of instructions to be able to do that. Okay, so when you fingerprint, similar to footprint, you can do passive fingerprinting. This is a way that we can observe network traffic and analyze the response in your network communication through the packets to determine the OS. So they designed a tool where it's going to submit it's use a script to submit the packets to that system and look at the response and say, Linux operating system respond way 1, right? Compared to Windows, it respond way 2. There's different ways that the operating system respond. Mac OS respond way 3. The nature of the operating system has different responses. And that's how these tools are going to tell you, oh, this is a Unix or Linux based. This is Windows based. And in some cases, they've gotten really close to where this is Windows 10, Windows 11. But sometimes it cannot find the detail, right? If you have proper security configuration when they scan you, it says operating system unknown, right? So when you see the unknown, that just means that when it submits these requests, your system is not responding in a way where it fits case 1, case 2, or case 3, right? It doesn't match up, so the tools is like, I don't know what that is, it's going to be unknown, right? You see that too. So your active fingerprinting, it's a way that we can send the probes, and typically that's scripts. So then the tool is going to give you the analysis of the result. Nmap does this. Now, most attacker, unless they're insider, they are going to fingerprint you from a remote system. A lot of the time they spoof it, so you can't identify who they are, right? Because we might block their traffic if we know who they are. So remote fingerprinting is a way that we use remote tools and services to remotely connect to that system and launch a scan to see what OS it's running. So you can't just go to the settings and look. Basically, these tools is gonna run a bunch of requests. It submits the request and wait for the response. It's gonna put together like, is it Linux, Windows, Mac OS, etc. Typically, you don't have Mac OS as server. Okay, you guys know this if you use Apple, right? You might have it for like local multimedia server, but we don't. In enterprise level, Linux or Windows, those are the two. Okay, so when do we do remote OS fingerprinting? This is when we need to have access to the target, but we cannot physically get to the target, right? So let's say that I'm in Ukraine and I'm targeting a company in the US. I'm going to have to perform OS fingerprinting remotely, right? Or when you're doing large scale fingerprinting. So in an enterprise environment, you don't just have like a few servers, you're going to have thousands of servers. So when you're looking at like Amazon, Microsoft, Google, large companies, even tech or not, right? Even for retailer, they're going to have thousands of servers across their infrastructure. So you're going to have to fingerprint most of their servers. Because the more you know, right, the more you can reduce that vulnerability as a pen tester. But from an attacker standpoint, the more you know, the likely that you are going to be, the probability of your success is going to be higher. So when you do pen testing, you have to think like an attacker, right? So we want to know what they know, and so that way we can close out the gaps. Any question? I don't know. Last night the back screen was mirroring, and then I came in today. Someone had left the configuration with the previous session. I gotta talk to the person that's using the room in the morning. It keeps doing that because they changed that, and then when I log in, it's that. So sorry if you're looking back there and you're not seeing the same projection. It's not mirroring. We've been trying to fix this problem in here. Okay. So in the notes, you can also read the details, right? I put some information about like whether it's using encryption and then SSH banner, definitely using encryption. So it needs to decode the banners, right? And that's going to tell you the configuration and the connectivity of that server. And then operating system fingerprinting is on page 5 through 8. I know that CIS25 also covers quite a bit of operating system basic configuration, right? So if you've taken that class, you probably, because that's basically CompTIA part 2 is that and troubleshooting. A+. Core 2. Okay, so when we get to page 6 in the middle, it talks about the elements that you need to understand about the operating system. So how can it tell whether it's Linux or Windows or Mac OS? How can it tell? So these are the 4 things that's going to distinguish your operating system. You need to know this, right? 1 is TTL is time to live, right? In most communication type of environment, you're going to have a TTL. This is going to be a set time for that packet to continue or be alive. Okay. It doesn't go forever. There's a time window that it's going to live. And in different operating system design, it's going to be different. So Mac OS is different than Linux and Windows. That's how your tool is going to know which one it is, right? And then window size. Window size for each operating system is set differently. So if you have taken upper classes, like for computer science, they might talk about like when you build an OS, this is what the elements for it, and this is how it's constructed. So the nature of the OS is really tied to these four. And then your DF is called the don't fragment bit. This is the bit that's used. So if there's a bit that's set, that's going to distinguish, these bits are going to distinguish your OSs. And then type of service, which is TOS. And this setting for the operating system is going to also distinguish the OS type. Any questions? So this class makes a lot more sense when you're like, oh, I learned this with CS25 about the operating system, right? And then now you see how, from a perspective, like if we're looking from a third perspective into the OS, what it looks like. Okay, so how can I fingerprint? I would use Nmap, EtherCap, or P0. So here is, we just covered number 13. You can grab that information from page 6, or you can retype that. So time to live, right? That's going to be for your outbound packets. That's the window of time that that packet is going to stay alive. And then your window size, and window size vary from one OS to another. Then your DF, don't fragment bit. And then for your type of service. So even if we run these scanners, like I said, right? Scanners are mostly gonna give you what you need. Sometimes it's inaccurate, right? You need to make sure that you correlate your results, because we run one scanner, we're gonna get one set of results. We want to confirm that with other results from other scanner. So if you're producing the same results across multiple tools, then you have consistency. Okay. And one tool might take you hours, right? Depending on your communication, security configuration, how that system responds, if there's anything that's blocking, etc. Bandwidth, there's other factors. Okay. So like I said, patience. Okay, let me move 13 down. So sometimes you have false positive or false negative results. In a false positive result, you're going to get incorrect operating system that was identified, leading to incorrect assumption of your vulnerability. So let's say that I am targeting a Windows system, right? Windows, let's say Server 2019 in specific, but it's giving me like a different version of Windows, like Windows Vista or something older, right? Typically in a server environment, we upgrade from like, 2008, 2012, 2016, 2019, 2022, and so on. And moving forward, you typically see the upgrade. So sometimes when it fingerprint, it might give you like the original version that you had, right? And it's not able to catch the upgrade. So when I say upgrade, is when we install the newer version or we upgrade it to the newer version. Most of you know this, right? So if you get a false positive, it's just not able to identify that correctly. Or sometimes it gives you Linux instead of Windows, right? But typically it doesn't do that. It tells you unknown if it's not able to identify. When you get a false negative, it does not contain any OS information. This is what you see with unknown, right? Leaving the system vulnerable to attack, especially when you're looking at ways to target the OS from an attacker standpoint. So even the Kali Linux, when you boot, you see it tells you potential threat issues, right? Potential exploitation because of this daemon or this kernel, right? In most Linux cases or OS cases, in some cases, kernel is an issue, and a threat can capitalize on that. So basically, they exploit that vulnerability, and there you go, right? So Eternal Blue, we talked about that I think last week, right? Just capitalize on Windows issue. So like SMB, which is a service. So how can you know like which operating system is good or bad, right? You go to the vendor website, they document by regulation, the vendor has to give you CVE information, common vulnerability issues. Typically they rank that. I just went over this with my analysis class last night, like how they score the vulnerability and then be able to publish that so that way everybody knows. So we share that information. So if you write a software, if your software is vulnerable, right, the requirement is that you update your software. So if you push it through like the online market, like Apple app market or your Microsoft or whichever, right? When you go through that, you pay them, but you also it checks, right? And it requires you to be able to maintain your software. So this is what you see with updates and so on. Sometimes they scrap the previous version and you see this on phone apps, right? Sometimes you had an app and you were using it, it was fine. And then you upgraded your Android or your iOS. And then, they came back and they redesigned the app for the new operating system, but also closed out some security issues. So you have to reinstall the app instead of updating the app, right? Okay, 15. What technique is used for operating system fingerprinting to identify the specific operating system that's used on the computer or the network, right? On the devices on the network, and then examine the unique characteristics of its TCP/IP stack. So all systems is designed to communicate, right? We sometimes have standalone system, but standalone system has the capability to communicate, right? To be part of the network. So it uses TCP/IP stack, so all system has to have an IP address, whether it's private local area network or public, right? Like your phone, it's able to communicate with the mobile network and also your home network via TCP/IP. It also, so that means that we would be able to fingerprint this stack by using network packets. So how can we do that, right? We're coming to a close. So I want to give you time to work on your lab today, a little lengthy. So what techniques are used to perform this type of fingerprinting? Well, it's always going to break down into two areas. One is going to be active and one is passive. So the active fingerprinting on TCP/IP stack, basically we have crafted packets. The tool has crafted packets that's going to submit the request to the target using IP address. If it's a domain, the domain name, right? So when it executes that function, it's going to launch these packets. This is just like network traffic. So it's going to dump the network traffic toward that system and wait for the response. And that's what the response is going to tell us, right? The things about that system. For passive fingerprinting, it looks at that system network communication, how it communicates, and gather the information, like header, right? So if the system is running certain services, it's going to pull that information and it's going to determine the behavior instead of directly interacting with that system. So it's kind of like this, right? If I'm your close friend, I know exactly who you are. So in the case that if you're actively fingerprinting, you become that person's close friend. You know their habits, you know who they are, how old they are, how they act, right? What kind of food they eat. Okay. But passive fingerprinting is kind of like I stand back and I watch you go by, right? Let's say you go to a restaurant, I look at you, and I assume that you like burgers, for example, right? So active is it really interact with that system directly, where passive is kind of like a watcher, okay? And determine based on the behavior of that system, how it communicates, how it responds to other systems. And then, so, you ask, well, is it accurate? Sometimes it is. It depends on the quality of the tool, right? So if the tool is designed to dive deep, and with that, you kind of have to give it time to really analyze the specific response to be able to determine the target, identity, information, and so on. Okay, so there's some advantages of operating system fingerprinting. I think we also covered, right? So when you fingerprint a system, really you're pulling software information, right? You're pulling their communication information. You pulling the services that they use, and all services ties to a package of software, right? That's installed and be able to execute certain things. So that's what you see. Okay. I know that in the exercise, I only mentioned a few common tools, which is what you see, right? Those things can get you by on an interview sometimes because most if you interview for a pen test position, even when you pass a certification, they're gonna ask you the basics so that way to see if you know. If you don't know the basic, then you don't know the advanced thing, right? So, so those common tools is gonna give you some leverage, but also, when you do that as a practice, the industry support those common tools. So here are some of the additional tools that you can use. Typically for this class, when I put together these notes, I spent a lot of time like looking at and this changes too, So that's the demand in this industry is that you might use this tool this year and the next year it goes away because they stop supporting it. Then you're like, oh, I have a good old tool, but then now it doesn't work. So, and then also the services change. So you have to update yourself with the new tool. So, there's passive and active ones. So I list some of the passive ones, right? Like Netsloth. And then some of them are proprietary. And then there's Queso, right? So when you develop your tools, you can name it anything you want, which is kind of cool, right? Okay. Now, how effective are these? Like I said, quality of the tool, you can go to the community and find out. Unlike forensic, these tools they don't go through validation and testing. So it's basically, if they improve the tools over time, so you want to get the latest version. So EtherCap is kind of like your Wireshark, right? Nmap, you have a little bit exposed to that from Lab 1 and a little bit in today's. And then um, so for TCP IP stack, Satori is useful. Okay. So what you can do is you can start with like a Linux virtual machine. Kali is a common one that everybody goes to as a foundation, but you can use other and customize your own, or If you're hardcore, you can use FreeBSD and then customize your operating system. Anyway, and then you add in your tools. So Kali already have a set tools that they have built with for pen testing, and that's good to practice on. And then I typically have you do sudo app install so you can add in the things that you need to use if it's not already there, right? And you can use which command or version option to determine if the tool exists already in your system. And Kali, if you click the dragon button, it drops down all the categories of your tools. They do a good job with adjusting that and keeping up with it. So I taught like this type of class since Kali before Kali, right? So, there were other operating system that is similar. Kali kind of came about in more of the recent years because there's demand for it. But before that, there was another name for it. And then even before that, you kind of had to do your manual stuff. So. And then if you get really good at Kali, right, and you want a red team, you can go for offensive security by Kali. That is a highly demanded certification for a lot of pen testers and Red Hat people. So I can share with you that information, or you can also research it online. All right, we're going to stop here.